time I will be able to have live streaming on Henry's Vasilo. Okay, it's part of chemistry, gas problem solving. Okay, yesterday I already discussed the Henry's law equation, the Henry's law basic concepts and principles. Okay, what is all about, and then it's about time to solve problems, gas problems regarding that Henry's law. I have four items or four problems, and then you can also uh, get a piece of paper to solve that one also. I will show you now. Okay, but this is okay. As you can see, Henry's law. Okay, by the way, this is I am a singer in a voice. Okay, if you want to be updated plugins and live streams, just follow me and click the notification bell. I am a singer, eternal voice, and then you'll be able also, if you this live streaming is beneficial to general audiences, especially you, then you can share it to anybody because this is very highly educational. Okay, for example, if you have a daughter or a son that is studying in chemistry, high school education, or first year college or second year college, then it's about time to listen to this topic also because it's one of the topics of chemistry, okay, regarding gas problems. A lot of gas problems, right? We have already discussed a lot of problems. But the problem is during chemistry examination, or let us say science examination, so it will be rumbled, it will be mixed. So the problem is there are a lot of gas problems formulas stuck in your mind, and then you have to uh, detect or try to have the appropriate formulas for the particular problem. Okay, like this. This is often not practiced, okay, and not neglected to in the social media world because all of us are focusing on our personal whereabouts, okay, personal affairs, personal engagements, personal events, such as like this, and then we also fail sometimes to gain academic information that we will be able to share also to our daughters and sons also because they are studying, right? So in order we can mold their young minds, we need to educate them also regarding academic information because family is the basic unit of society. Okay, it's not the school. Okay, family is the basic unit of the society, and then in which we need to educate our children regarding the good values, attitude, not only that, and also academic information. We will be able to share that with them. Okay, so this is very educational, but of course I cannot discuss all topics also. I must choose only one topic in a day like that as per my uh, inclination, meaning to say uh, things or topics that I am enjoying the most, in which I learn the most, something like that. Okay, because there are areas that I'm very weak also, and there are also areas or subjects that I'm very strong. So I will focus more on the subjects or topics that I am very strong. Like that, okay? So hoping you guys will spend time for me now for my live streaming. So I am a singer, eternal voice, okay? Just go to my YT channel, see a lot of videos classified there. Okay, we have the personal vlogs, we have the science and health. Okay, oh my God, we have um, music and entertainment, singing like that. So a variety of laggings and streams. Okay, like that. So go back to our main topic for this live streaming. This one. Okay, can you read in the screen? Henry's Law. Henry's Law. Problem solving items 1 to 4. Okay, let's go now directly to problem number 1. Okay, I'm asked to read first and I will show you the problem in the screen, right? Okay. The solubility of carbon dioxide solution is 0.0003 molar means moles per liter at 1 atmosphere. What is the solubility of carbon dioxide at 6 atmosphere if temperature remain constant? Okay, this is the problem. Okay, solve it by yourself. You can remember the two formulas of Henry's law. Okay, I'll give you 5 minutes. Okay, so don't be to for topics because we are presently discussing the Henry's law. And also try to connect other gas laws equations also because this might those might be applicable. You can solve this in your own manner, okay? And then if you have principles and connect that with this formula, okay, the Henry's law. Okay, so our formula will be used are two. We need to choose the formula. Okay, wait for a while. Gosh. Okay, solubility of a gas. Meaning to say solubility of a gas in a solvent. So meaning to say we're referring to the solute. So normally this is a liquid solution. So mostly water, okay? Because it will not be uh, applicable to any solution also like that. So this is mainly for liquid solution, pure water, something like that, okay? Because we can easily assume the density of water is equals to 1 grams per milliliter. But for other chemical solution, you have to, alert to find it in the physical properties in the chemical engineer's handbook books, okay, or even in the Google Chrome. So to avoid that one, we need to focus on the water solution, something. So solubility, our solution is this. Okay. Okay. Given something that you will start with a given. Okay. Given. Given. Okay. Given means the data that are okay being shown the problem or stated in the problem, something like that. Okay. So CO2. Okay. CO2. So the molarity is equal to the solubility. It's just the same, okay? Do not be confused with the term because molarity and solubility is just the same. Solution, something like that. Our solution is carbon dioxide and a liquid, okay, something like that. Okay, and CO2 is the gas, of course, so something like that. It's not mentioned, but it understood, okay? So 0.0003 molar, then moles per liter, okay? This one, 0.03 molar or moles per liter, that is our solubility of the carbon dioxide, okay? And then, what is the solubility of carbon dioxide at 6 atmosphere? So the required is the solubility, okay, solubility, sorry, at 6 atmosphere, okay, 6 atmosphere. So our solubility S2, okay. Okay, S2. So there is initial and final stages. Okay. S1 and S2. Of course, if there is an S1 and S2, initial solubility, final solubility, there must also have the partial pressure initial state and the partial pressure at the final stage. Okay, something like that. Okay, so our take a look. Okay, our solubility 2 or S, okay, is the required, but we have the atmosphere. So this is automatically our P2. Okay, so P2, this one, P2. So you have now already the P2 and S2, the solubility of carbon dioxide at a final stage, and the partial pressure of the carbon dioxide in the final stage. Okay, and you have the initial uh, solubility, which is equal to 0.003 molar. So it is very clear that we have now three given, okay? So we need to use the second formula of Henry's law, gas law equation, okay? The relationship between the initial and final stages, okay, involving partial pressure solubilities, something like that. Okay, it's very clear, okay? Like that. So we use this formula, P2 over P1 is equals to S2 over S1. So all you have to do is to determine the given and the required, and you have to find an appropriate formulas for the particular problem. Okay, like that. Okay, and then if your instructor or let's say if your professor is discussing that present topic, okay, of course you need to focus on the present topic, but do not forget to the previous topics because there are formulas in the previous topics that you're going to connect also with the present topics, okay, like that, so that you will never be lost, something like that. And if it is necessary to derive an equation out of the analysis, okay, regarding the problem. Okay, because there are problems that needs to be analyzed as direct substitution. Okay, what we call in algebra, that is shift solve equation, or what we call as linear equation. Okay, let it be one variable, two variables in a linear equation. Okay, that is very easy to solve. But what if there are a lot of required, let's say it involves three, okay, variables to be analyzed, something like that. Then you have also three equations normally, something like that. And we have to equate like that, basing on the previous equations, previous topics on gas problem, something like that, okay? Like that. Okay, this is our equation to be used. Okay, P2 over P1 is equal to S2 over S1. S2 is the solubility, and P2 is the pressure or partial pressure. Okay, 1 and 2 is only identification that is in the initial stage, and 2 is in the final stage. Okay, like that. That's why it's represented by 1 initial stage, 2 represented final stage, like that. And you have to substitute now. Okay. In this equation, the Henry's law constant is not applicable. Okay, take note. Gosh, it's not applicable. So direct substitution. Okay. In the examination, especially the PRC or Philippine Regulation Commission Board examination, it should be engraved in your mind that the questions will be given are not all difficult. I'll tell you frankly, them are average problems, okay? And there are also easy problems, and of course there are difficult problems. Of course, they will not give too much difficult problems, because if that is the case, all will fail. Okay, because they also know in the first place that not all students are intelligent enough to answer those questions perfectly. Normally, they will give more average questions rather than difficult problems. Only that the students who will be taking the particular board examination are thinking that those questions are difficult. Okay, so meaning to say, it also affects the mental state of mind or our how we psychologize things, something like that. We think that it's very difficult, but then if we try to read it again, review it again, blah blah blah, so and so, then you're afraid. Just go for it and then try to incorporate the most appropriate formulas for that. You can the question and mark well answers, something like that. Okay, don't be afraid. Okay, something like that. So that's the technique really in passing the examination, whatever type of examination. Do not be afraid. Okay, just focus on what you have studied. Okay. Okay, P2 and acronym, hint and clues should be engraved in your mind. Engraved meaning to say it should be retained. Oh my gosh, retained. Okay, in your mind, something like that. Okay. So this is really a good exercise of our mind. Okay, we exercise our brain, health, mental health, something like that. Okay, so usual, something like that. Okay, so hello guys, the microphone is low sound. Okay, so we are doing now mental health exercise like that. Okay, and then to quickly recall uh, past academic information. Okay, that will also be useful in our, let's say, career, work, or whatever we are facing in different endeavors, then we can use also. Okay? Okay, it should be balanced. Okay. I also post comments in Facebook. I also, post some photos in Facebook, try to comment, but, it's also to be school, okay? My course is broadcast journalism, right? Then it was government scholarship at the time when I was in college, okay? And then it was not mentioned mass communication major in broadcast journalism. Okay, I like this course too much. So what we, again, I have to tell you that engineering courses are listed there in the scholarship, and I have no choice. I have no choice is to pick the most near engineering course. And I think to myself that I am very, not very, I am really loving the chemistry, okay? And then efforts that match. TH, capital T, capital H, try that you can pass. Okay? Like that. Okay. So P, going back to the problem number 1, okay, P2 over P1 is equal to S2 over S1. Okay, so P2 is 6 atmosphere, okay? My God, 6 atmosphere. And you should remember also the equivalence, in pressure. Do you still recall that one? What 1 atmosphere is equals to 14.7 psi, like that, okay? 1 bar is equals to 101.325 kilopascal, or 1 atm is equals to 1,325 Pascal, something like that. And you can simply convert that one. 1 atmosphere is equals to 760 mmHg. Okay, remember the 760 mmHg. mm is the unit of distance, And then, for example, if there is a problem that requires what is the distance and the pressure is given for the distance because there's millimeter. Okay, you will be afraid because the unit is pressure. I know that. Distance is very far from pressure. Okay? Height is very far from pressure. Okay? But there is 760 mmHg. mm is the distance or height. Then you can compute for the distance or height through using that 760. The unit also have the variable of, for example, pressure, temperature, like heat, energy, like, okay, velocity, centripetal force, centrifugal force, and then like revolution per minute, RPM, like that. Okay, a lot. Centripetal force, centrifugal force in physics, right? You can remember. Okay, force, a lot of variable to be taken into account. Okay, something like that. And what I discussed a while ago or previously, you should also retain in your mind, something like that. Okay? Going back to the formula, 6 atmosphere over, or P1 is 1. As you can observe, I really discussed basic. Okay, because the basic concept, because the basic will be helpful. Okay, rather than going to the rigid, solid foundation of the basic concepts and concepts, then it could be applied in a more complicated problems. Okay, even though it's being mixed, it's being rumbled, then if you have the basic concepts and theories, principles, and laws, then you can understand also. Okay, connecting the dots through connecting and linking the different formulas. Like that, you should also analyze. Because sometimes mathematics will be used also. For example, twice as blah blah blah, okay, decreasing as blah blah blah. So you have to remember the algebraic expression. You know, algebraic expression. Okay, equals like this. Okay, as much. Okay, plus more than. Okay, less than, so minus, like this. Okay, so in words, but have equivalent mathematical operation. Okay, like that. Okay, is equals to S2 over S1. Okay, so we have S2 is our unknown. You can put as question mark or simply S2. Okay, like that. And then S1 is 0.000003. Okay, like this. Okay, I substitute already the values. Okay, plugging in the values and then do the basic mathematical operation. Okay, this is a cross multiplication. Okay, in mathematics, basic algebra, linear equation only. Okay, like that. So cross, meaning I have to put like this. So see, cross. Okay, so you have to multiply the diagonal first on the other side, and second the diagonal on the other side. And let's say 6 atmosphere. You can also remove the units if you're very expert enough. Okay, but then I advise not to remove the units first in order to illustrate the proper cancellation of the units, because it will confuse incorporate the unit in the formula, because you need to be faster to solve quickly, because there are still another problems waiting for you. For example, the day one examination for general engineering is 100 and you are still in the number 50. Okay, then you are too far. Then trust think, then you need to put the units also, something like that. Okay, it depends on the situation really. Okay, it's in order we can have upper class also. Okay, 6 atmosphere. Okay, 0.0, and then we will use the moles per liter for molarity. Capital M is the molarity, and then the small m is the molality in chemistry. Okay, small m is the molality, big M is the molarity. We can name that as molar or moles per liter. Okay, 0.00003, and then like that. Okay, molar. Okay, and then S2 times 1 atmosphere. In my case, I need to cancel directly. Okay, para pwede na siya bulubo, something like that. Okay, I will cancel immediately the atmosphere from the left side and the right side. Okay, so that it will become simplified, something like that. So cancel the atmosphere. What's been left is the molarity. Okay, do the calculation. You cannot calculate this in your mind because there is 3 zeros. Okay, like this. Okay, like this. 6 times 0.003 times, oh my gosh, okay, 6 times 0.003 is equals to 0.0018. Okay, this will be our solubility 2. Okay, so this is our solubility of carbon dioxide at 6 atmospheres. everything like this, okay? Ano yun? 0.008. Okay? And then this is molar. This is the answer. Okay? The answer will be 0.0018 molar for solubility 2 or solubility of carbon dioxide at 6 atmosphere. Sometimes for example, if this multiple choice examination, okay, they have the exponential, okay, to avoid writing too much zeros, okay? So you have to adopt the rule of, exponential, okay? Like in this case, because you are going to right, okay, and then you have to put negative, okay. So this is the same as, so move to 1 2, so 1.8 times 10 to the negative 2 molar, okay. Because there are times that the choices has no whole figure, then the choices are only raised to the power something, and do not be afraid, it's just the same, okay, like this, okay, molar or moles per liter, okay, that will be our answer for question number 1, okay, 2, sorry, times 10 to the negative 2, okay. And I can also answer this by using the basic concept without using the formula. Okay, I will show you. Okay, in our problem we have a pressure 1 is equals to, okay, 1 atmosphere, right? Okay, and the solubility of carbon dioxide is 0.003, right? 0.003, and the P2 is 6 atmosphere, okay, and what will be our solubility 2? Okay, this one. So we have this relationship, okay, at pressure 1 is equals to 1 atmosphere, our solubility or concentration in moles per liter or molar is equals to 0.0003, okay, like that, okay. And in our P2, 6 atmosphere, our solubility how much? Since you know already the concept and basic theory of Henry's law, that the partial pressure is directly proportional to the solubility. Okay? Now, if 1 atmosphere is raised to 6 atmosphere, then you have to times 6 only the solubility. Okay? Directly without using the formula. Okay, so directly proportional with each other. When the partial pressure is higher, the solubility also is higher. Then since you have the reference pressure, okay, so you should multiply it only by 6. So like that. So 6. Okay, so 6 times 0.08, okay, is equals to 1.8 times 10 to the negative 2 molar. So in this case, if you forgot the formula, you can still solve by having the basic. You can still solve by having the basic concept. Okay, due to the, it's directly proportional with each other. Okay, the higher solubility, the higher partial pressure. So to increase the atmosphere to 6, we should also increase the solubility to 6. Okay, so times 6. Or we can also do this in mathematics, the ratio and proportion. Okay, ratio and proportion. You can solve this out. Okay, because we have the same relationship. Okay, you cannot do the ratio and proportion if the problems have no the same relationship. So this has the same relationship, okay? Like that. So 3 methods. The theory and concept by the formula. That's question number 1. Thank you so much. And we'll go to question number 2. Guys. Okay. Number 2. The solubility gas times 10 to negative 3 is the solubility, the pressure like a shock. Okay, so don't be afraid with it. Okay, because the tour is not really that familiar or popular compared to the atmosphere, the PSI, the bar, but still, that's a unit of 4 is equals to 1 atmosphere. Okay, so in this manner, already, okay, the solubility of a gas is equals to Henry's law constant times the partial pressure of the gas. Okay, like that. Take a look. Okay, this one. Very easy because it's only direct substitution, right? Okay. Okay. Do not be afraid with the exponential. We can adjust on like numerical figure in decimal places, decimal points later if you want to. Okay. Like this. Okay. Our formula in this case, we have the solubility of a gas. So in this problem, this is general because the gas is not mentioned. Okay, only solubility of a gas. This only will measure your analysis for this particular problem. So solubility of a gas. This is a known gas, right, or general. It's equals to the Henry's law of constant of a gas times the partial pressure of the gas. Take note, my friend, or take note, my brothers and sisters in Christ. Oh my gosh. Okay, that the the gas. So all are gases. Okay, so you don't need to input solids and liquids in this particular equation. So that is your first identification. Because if you try to put that one, this theory of Henry's law will be no longer applicable. Okay, do not mix the 3 phases of matter: solid, liquid, and gas. This is about gas. Okay, very clear, gas problem, as I mentioned in the first place. Okay, or unless there's a dissociation reaction in the problem. Okay, but this is applicable for liquid solution in a gas, something like that. Okay, sometimes the problems will also give the density of like this, and it's not being the density of the solvent like that, and gas is the our formula, and then you will just try to force it to put on the equation problem. Okay, like that. You need to visualization also. Not only the brain, also the eyes sometimes, okay? And made us mistakes, okay? Like that. So where Henry's law constant. Now class talaga. If Henry's law constant is not mentioned, and then you are obligated to get it in the books, okay, or in the, for us, in the chemical engineer's handbook, okay, because there are a lot of physical properties, constants in the chemical engineer's handbook, okay, on solubility, partial pressure, atmosphere, temperature, viscosity, density, certain substances, okay, all are being mentioned there, the boiling point, the freezing point, okay, like that, okay. So our K of the gas, or our constant, solubility gas constant, is 1.5 times 10 to negative 3. Ang kani siyang mole, mole, ano? Mole times L negative. Okay, we'll just put the letter into down in mathematics, right? If we transpose the unit into the denominator, then it will become positive. Or reverse, if we have the unit in the numerator, negative, or positive, it will be negative in going downward. Or vice versa. If our denominator also will be transposed to the numerator, then the exponential will be changed its signs from positive to negative, from positive to negative. That's the rule for division of exponential. Okay? That's a topic also in algebra. okay, exponential rule, something like that. Okay, so 1.5% to the 3 mole. Put the letters downside, okay, because it's L negative. See, the problem is just confusing the students, okay? Why putting directly moles per letter? Maybe in the encoding, very difficult to put on the keypad, the denominator L, something like the keypad in the, in the laptop, in the mobile phone, maybe during the making of the questions, okay? Because it's very easy. Letters downside, and why going it up? Then the students will be confused. Why letter negative? Something like that, okay? And then if you forgot the algebra rule, he will be trapped or she will be trapped again. Something like that. Because not all students have quick memory, something like that. Some other students also cannot recall immediately the lessons in the past. They don't know that those lessons in the past will be interconnected in the lessons in the present, something like that. And especially if the instructors and professors did not put that in his or in her examples or in her discussion, then that will become a problem because all of his examples and her examples are all the correct unit. Okay? And then during the examination, she or he tried to reverse the unit and tested you if you really understand the theory of algebra regarding the unit transposing or the exponential, something like that. Okay? So that is moles per liter. Okay, we could adjust downwards, so it becomes liter positive. Okay, then times the pressure of the gas. Okay, the pressure of the gas is automatic 500 torr. Okay, like 500 torr. So your answer is normally 500 mole torr liter, something like that. Okay, solubility. Okay, multiply it directly. Oh my gosh. Okay. 1.5, 500, 750. Okay, like that. Times 10 to the negative 3. Okay. This is our, okay. Right. Okay. Now, okay. As I see the equation, did you observe the equation? Okay. The solubility gas constant at 20 degrees Celsius is 1.5 10 raised to the power negative mole per liter. Okay, when I substitute that to my equation, and then I found out it will not be cancelled the pressure. Something like that. This is analysis actual also. Because if you have the actual analysis and actual review, you can also the if you are wrong or not. See like this during vlogging and live streaming that is not scripted, not scripted meaning I did not practice what to explain or what to do like that. Though I have the problems, solve this in actual, something like that. So for example, for the purpose of the okay, because you are in the one during that one perfectly. But in my case, I did not do that. Okay, so there are times that I got mistakes during my explanation, okay, and in my computation because this is on the spot. Okay, so this measure really our previous learnings in the past and connected it to the present learnings by reading, research, something like that to to everything. So if that is the explanations will be perfect. Okay, the students also will think, this guy is very intelligent, something like that. But there's no such like that. There's no such perfection. Even though you are magna cum laude or whatever, you can still be mistake, right? So there's no such perfection in this contemporary world. Okay, that's why I'm trying to have my discussion about. Okay, but I prepared topics first. Okay. Okay, in this case, we memorized the formulas. But in this case, I found out, because if this is scripted, I don't have to put the given wrong. The given is wrong really. We have to put the atmosphere in the denominator. See? So if the students are very alert to detect that one, they understand what is really the topic all about. Me, I review. That's my procedure also. For example, if I write articles, for example, in editorial, so before editorial, I join editorial writing competition, something like that, or whatever articles that I've made in my college education before, okay, I have to review that one also, especially the grammar, the spelling, the phrasing of the paragraph. Okay, would it be okay like this, blah blah blah, so and so on. I will try to remove the redundancies, something like that. This also is review. For in this case, I put the problem and I missed. Okay, there must be over atmosphere. Okay, atmosphere like this. Sorry, sorry. Okay, so there must be atmosphere here. Okay, like that. Okay, so pag siya ang pressure, ganaman siya the only problem is that atmosphere and total will be covered. As I told you earlier, we have the conversion of 2 to the atmosphere, 760 total. Okay, like this. 504. It's so enjoyable, right? Okay, and then 180 N. Hello guys, I'm telling you every time during my vloggings and streamings to correct me on the spot because I will issue a statement also, okay, in my video. I will put that in my description also, okay? Like that. That is my culture in doing the things and live streamings, that if found out that I got mistakes, then you have to correct me through comments like that, okay? And then I will try to apologize for the erratum or the errors for the particular region, something like that. Because we cannot have a perfect explanation also sometimes. Especially me, I do it in a spontaneous, meaning to say on the okay, not prepare something to talk. Okay? And then my tongue will be slide or slip. My tongue will be slip because of too much formulas on my mind accumulated, and then I forgot to to state it or emphasize it perfectly also sometimes. Okay, like that. Okay, cancel. Okay, blah blah blah, so and so. So atmosphere, cancel also. So our unit now is moles per liter. Okay, this is it, pencil. Okay. So we need to, in this case, okay, we need to ask moles per liter. Okay? Okay. So this is our molar. Solubility is in molar. Capital M ha. Why in a laboratory found a big letter M for reagents? Because that's molar spread. Okay. Let's divide first 500. 500. Oh my god. 500. 500 divided by 760 is equals to 0.6578 times 7, okay, divided by 760. May calculator. This is a scientific calculator, okay, times. I will convert first the times -3 because it's just very small, right? I can still manage going to the left. Okay, so move 3 places. -3, so 3 places to the left. So 1, 2, 3. Put zeros like that. So, okay, like this. So that we can easily manage. Because it's still, it's still easy to multiply because the exponential is not too many or too high. 500 divided by 760 is equals to, okay, 0.65 equals to our solubility 0.0049. Okay, molarity or molar. Okay, then it could be in exponential with kung siya sa right. Okay, so 4.9 times 10 to the negative 2 molar. This is our solubility of the gas. Okay, this one. Okay. Okay. There is the institution. Okay. So we will analyze. Okay. So at 500 torr, our molar solubility will become 4.9 times 10 to the negative. That's question number 2. Oh my gosh. Question number, what concentration of salt dioxide in a 2-liter bottle of soda? Soda meaning soft drinks, right? Because there is water, and we know that soft drinks, or let's say cola or whatever, soda drinks will generate carbon dioxide if you open the cover, the ring. Okay, and then if you open it like that, so the pressurized carbon dioxide will escape. So this is the principle of this problem number 3. Okay, if the pressure carbon dioxide using that process will be all soft drinks and with carbon dioxide. Okay, assume the solubility of carbon dioxide in the soda is the same as in the pure water. The Henry's law constant of carbon dioxide in water at 25 degrees Celsius is 3.5 times to moles later as like that. Okay, so we need to show to write together first. Saan ba siyang soda? Saan ba yung formula ng soda? When we speak about soda, there is sodium. Because as far as I know, we have baking soda, baking food, and the formula of it is sodium bicarbonate. So if it is okay, so there's sodium. Okay? Sodium. So it could be sodium oxide or it could be sodium hydroxide. I'm not really sure. As far as I remember. Okay? Because soda is in words here. It's not in chemical formula. Because we don't know also, maybe this soda also will take in the reaction. Okay, and then we need this also. Let's find out. Okay, and then so we need to determine the chemical formula of soda. Okay, so it could be sodium hydroxide, or it could be sodium oxide, something like that. I'm not really sure. Okay, as long as there is sodium in the compound, I'm sure. Okay, it's like baking powder or baking soda. Okay. I think this is, wait for a while. Soda, I think this is sodium carbonate. Because, there's CO2, right? And then it will release CO2 in the atmosphere during opening the soft drinks, right? Then the sodium carbonate will release CO2. Imagining the chemical formula of this. Okay. What is the concentration of the dissolved CO2? Okay. Given. Sa talaga dito sa given. Okay. 2-liter barrel of soda. Okay, the soft drinks or the soda drink is 2 liter. Okay. 2 liter. 2-liter soda. Drink. Okay. The partial pressure of carbon dioxide, okay, the partial pressure of carbon, 3.20 atmosphere. Okay, if the partial pressure of carbon used in the bottling process is 3.20 atmosphere, okay, so it's already partial pressure, okay, it's mentioned, okay. Assume the solubility of carbon dioxide in the soda is the same as in the pure water. Andito na naman mga ganito eh. This really confused the students because assume, blah, 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 whatever. Okay? Then the Henry's law constant. Remember to assume the solubility of carbon dioxide in the soda is the same as in the pure water. Meaning to say, the solubility of CO2 is equal to the solubility of pure water. Okay? At 3.20 atmosphere. Okay? Assume. So because we can easily assume because the pure water has density of 1 gram per ml, which is the basis of most of the chemicals like this, blah blah blah, so on and so. Okay, that is 1 grams per ml. So based on what I remembered in chemistry, okay, at 25 degrees Celsius also, our density is 1 gram per ml. Correct me if I'm wrong. At 25 degrees Celsius, our density is of water is 1 grams per ml. Okay, like that. That's why sometimes they will never put the density in the problem anymore, like that, because it adds also confusion. Okay, assume solubility. The Henry's law constant is, okay, key gas or key CO2 na lang siya. Okay, because we identify the CO2, right? So Henry's law constant is equals to 3.1 times 10 to the negative 2 m atmosphere. Now I will teach you something. In this K constant, okay, Henry's law constant, do not split the molarity into moles per liter, especially with the problem are stating only the capital N, because it will confuse you during the cancellation. Just leave that as it is, okay, and just convert that in the last part, okay, okay, like that. So, what is the solubility of CO2 in a 2-liter bottle of soda at 25 degrees Celsius? Okay. So direct substitution din siya, in fairness. Okay? I think so. Oh my gosh. Okay, solubility of a gas, which is, I'll show you first the given. Okay? This one. Too much long. I'll give you 5 minutes. Solve that. 5 minutes. 5 minutes only because it is not very difficult. Okay? Okay, in this problem, we found a necessary variable that is not used in the equation. Example, the Henry's law is operating at a constant temperature. As we discussed in the theory and principle of Henry's law, that those solutions are assumed to be at a temperature, or the temperature is constant. temperature never change throughout the solution. So there's no changes in temperature. Actually, this is related to boil slope. The temperature is also constant, but the difference is more from the volume, the boil slope. But I mean, they have the same constant. The temperature will remain constant. Kind of problem, okay? Like that. Very clear now. Okay. I will got perfect for this, for solving this. It's not very difficult, right? This is only showing the basic concepts for how to solve the Henry law constant. No, what's it? Henry's law gas equation problems. Okay. I believe you can also solve for the constant. If the partial pressure and the solubility of the gas are also given, okay, it's just like that in the game, something like that. Okay. Last. Okay. Solubility of CO2. CO2 is okay. Just only applying the prefixes or okay. Solubility of CO2 is equals to the Henry's law constant of CO2 and the partial pressure of CO2. See? In our formula, all are 2. Okay. So soda will participate in this problem because it was assumed that the solubility of CO2 in the soda is the same as in the pure water shot. Okay, like that. Okay, and remember also that the pressure and solubility is directly proportional with each other. If the solubility will increase, the pressure also will increase, or the partial pressure will increase, sorry. Okay? Like that. So substitution na. Okay. (3.1 times 10 to the negative 2 is our Henry's constant times the pressure of CO2, but name which is 3.20. Okay. Okay, multiply it directly and see. You can process it immediately the atmosphere and your unit will be M. As you can see, I'll show you. That is molar. Okay. The technique is multiply the whole number first, or the numerical figure, and then later accounting the exponential. 3 times 10 to the negative 2, okay? 9.92 times 10 to the negative 2 molar or moles per liter. Okay. This one is the answer for solubility of CO2. Okay, or you can have that as, okay, going to the left. Oh, sorry, it's negative. Okay, I forgot to put the negative. Okay. Be careful now because there's a big difference. If you forget to put the positive and negative, then there will become a big difference in your answer in the problem solving. Okay, be careful. Always review. Okay, that's the best thing to do. Okay, 00992 molar. Okay, this is the solubility. Okay, this is the solubility of CO2 at 25 degrees Celsius. Okay. So why it is being assured that the ability of CO2 is so close to the water? Of course, because the CO2 is interacting in the soda drink. So this CO2 occupies there. So it will become directly proportional with each other. Okay? Because they're with each other. So the IMF, the intermolecular forces between soda, okay, and CO2 are being interacted with each each other. So that's what we assume. Okay? It's assumed, but at the same time, it has relevance or logic, scientific logic, why it is being assumed to be like that. Okay? The assumption is valid, what I mean. Okay? Because if your assumption is not valid, then that would be a wrong assumption. It can also lead to errors. Your assumption must be always near to correct or valid. Okay, that's question number 3. So we learned that so many given, but only less given are being incorporated to correct answer. So if this will come out in the word examination like this, even very long, and then some given are not used. Normally, it's gifted enough and have high IQ. All nine. Ay, nako. Okay. Stay with me, guys. What is the dissolve? See, constraint. Okay, the technique is constraint. Okay, it's just only synonymous term with each other. We can use that as solubility. We can use it as concentration. Like that. Or strength. You know strength? STRENGTH. That's also a synonymous term for concentration. Force is in the context of gas or gas problem. Okay. Gas in a mountain lake, if the atmospheric pressure, andyan na naman tayo, is 0.776 atmosphere. The mole fraction of oxygen gas in air is 0.21. The temperature is 25 degrees Celsius. See, as you can note, always 25 degrees Celsius. Okay. Give gosh. We have the Henry slope O2, the atomic pa rin siya, the atomic gas. So Henry's law constant is equals to 1.3. So the best thing to do not put the other given in your solution, which will add also confusion if you think that is unnecessary. That's only the the reference point. Also sometimes confusion like this. Okay, solubility of O2 is equals to Henry's law constant, the O2 times the partial pressure of O2. Okay. Okay. Textbooks, as far as I could remember in my college, they would put the underline at the top of the pressure. Okay, like there are textbook, old books, okay, before, like this, partial pressure. There's an underline at the top of the letter P. Just to distinguish that this is a partial pressure from the normal pressure, which is only P, right? But in most cases, that is understood to be partial pressure, so it's on your mind equation. Partial pressure. Like this. So, klaro kaayo. So, SO2 is equals to KO2 times PO2, partial pressure of oxygen gas. Okay? Substitute directly. So 1.3 10 to negative 3 molar per ATM. And now we have the pressure given, which is atmospheric pressure shock. Okay, atmospheric pressure, what do you mean this one? Atmospheric pressure. Atmospheric pressure is 76 ATM. So, we have atmospheric pressure equals to 76. We cannot substitute this to the partial pressure because atmospheric means, okay, again, atmospheric pressure is the total pressure of oxygen gas. Now, what is the formula for this? Okay, recalling the Dalton's law of partial pressure. So this is the of Engr law has partial pressure. pressure, connect that there. Okay, like that. And then we have the mole fraction of oxygen gas in air is 0.21. Mole fraction, as you can remember, we will represent that as X. So we have X, O2 is our mole fraction of oxygen gas. Okay, so XO2, okay, is equals to the mole fraction. Okay, because there are two formulas of mole fraction. It either be in terms of pressure consideration or it be by moles consideration. If we try to consider the pressure equal now to mole fraction of O2 is equal to the partial pressure of O2 over the total pressure in O2 is equal. You can understand the problem that is not focusing on the number of moles of CO2 and the air. Okay? Because this is CO2 and air actually. It will become more complicated because it is an atmospheric pressure in the surrounding. And then if you try to use the number of moles problem, you have to compute the number of moles of oxygen gas, you need to compute the number of moles for nitrogen, the number of moles for oxygen, because in basic theory, composed of 79% of nitrogen, and 21% oxygen. And that is percentage by volume. That is not by moles, number of moles. And you have to also figure weight, something like that. So how about using the pressures consideration, in which we have partial pressure of O2 over the total pressure, which is being mentioned to be equal to 0.776. And to the mathematical operation, you can simply multiply that 1. Okay, the total pressure and the mole fraction to get the partial pressure. Okay, like that. And you will be able to substitute that in the equation. Okay, like that. So connecting the Dalton's law of partial pressure to the Henry's law equation. Okay, like that. You'll be alert if there's a word partial, huh? Okay, something like that. So I have to incorporate that here, right? I will just multiply directly because it's just a simple mathematics. Okay. XO2. But I have to show the substitution, okay? It's equals to 0.21, partial pressure of O2, and total pressure of 0.776. Okay, this one is the other side. Like that. So multiply directly cross multiplication immediately. We have to multiply the 0.776 to 21 mole fraction and the total pressure. And you have to incorporate that one in solution. Bring that here also. Okay. 0.776 like this. Sphere will cancel. So molar will be left. Okay. Our solubility of oxygen gas will be calculator. Charot. Okay. Ba yan? 1.3 something. Gosh. This is 0.0013. Okay. Times 0.21. 0.7776. So 0.0013 times 0.21 times 0.776 equals 2. Okay, our answer will be 0.00021 or 2.12. 2.12 times raised to the negative 4 molar. This is our answer now. Okay, finish. Yes. So our 4 problems had been solved completely. Okay, review my answers and then correct me if I'm wrong, and I will issue error statement in the description of my video. Okay, like that. Okay, and then guys, don't forget also to analyze if, for example, if you're the total pressure, then you will try to determine what is the pressure of, let us say, nitrogen. Okay, like this. And then you know that there is a total pressure of 776. So total pressure is equals to P oxygen, partial pressure oxygen, plus partial pressure of nitrogen. Okay, so you can immediately get the partial pressure of nitrogen because air composed of nitrogen and oxygen. This is an example if the problem will deceive you pressure of nitrogen and you will be shocked. There's no nitrogen the problem, okay? But you know the theory that air composed of oxygen and nitrogen, and you have already oxygen that computed our partial pressure, right? So automatically we have the partial pressure of nitrogen without any explanation and chuba chuba chu chu, okay? Like that, okay? So our total pressure is 0.776 and then plus equal to partial pressure of oxygen in which nakuha na siya and then transposing linear equation you can get the partial pressure of nitrogen. Okay, assuming that there's still additional question for this number 4 problem. Okay, like that. Actually, it will create confusion if the problem will be rumbled already. Rumbled, you know, makes it's very difficult really to predict what formulas will be trying to equate for the particular problem. Okay, even though how easy it will confuse you really in actual. Okay, this is only good because this is not an actual examination, but in the actual examination, it's time pressure, and then all your senses will be used. Okay, the eyes, the brain, your emotions sometimes. Okay, like that. Okay, because you need to consider also the environment. Okay, like that in the examination room, something like that. Okay, so that's it. Okay, guys, thank you so much for sparing and spending your time with me in my live streaming of this Henry's low gas problem have been solved now. Okay, thank you so much. Then if there are similar problems like this, especially solubility and partial pressures relationship, now you can apply this, problem solving, especially in various examinations in the future. Okay, if you think that you like my video, then subscribe, comment, and share. And just click the notification bell for some newest updates of Sotero with regards to science and health, music, entertainment, particularly singing, personal vloggings, and others. Thank you so much for watching. Bye bye. God bless. Mwah.